Welcome back. In this video we're going to look at the determination of oxidation numbers. We've looked at a lot of elements in the periodic table that we know have multiple oxidation numbers, particularly the ones in the transition metals in the middle of the periodic table. It's hard to make a guess as to what oxidation number is something's going to be, but if you know what a compound that it's in, you can figure out just from process of elimination what a certain element must have based upon some other elements that don't change very much. So let's look at, first of all, a table, and this is not a complete table, but these are just some basic rules that's good to keep in mind. Any element that's just by itself, that's not combined with any other element, is always going to have a zero oxidation number. Any ion that's monoatomic, just one element that's an ion, will always be equal to the charge on that ion. So, and we've learned this before. Anything in group 1 is going to have an oxidation number of 1. Anything in group 2 will have a positive 2. Group 3 will have a positive 3. Group 4 is iffy. It could either be a negative 4 or a positive 4. It usually doesn't combine ionically. Group 5 will have a negative 3. Group 6 will have a negative 2. And group 7 will usually have a negative 1. Oxygen almost always has a negative 2. There is a peroxide ion that's negative 1, but that's very rare. Fluorine and halogens, if it reacts with a metal, is always going to be a negative 1. If it reacts with a nonmetal, it could actually be positive. Hydrogen with a nonmetal is always going to be positive 1, and hydrogen with a metal will be negative 1. So let's look at some examples. So let's start with hydrogen sulfide gas. We know from this table that hydrogen is positive 1 when combined with a nonmetal, so that makes it 2 positive 1s, and the rule says that any compound must be neutral. So H2S, there's no positive or negative there. That means it must be neutral. So sulfur has to balance with 2 positive 1s. So in this case, it must be negative 2 so that it can balance. So in a different example, it's not going to be negative 2. It doesn't ever have to be again. You just have to take it from its context. This one we have S8, and we see that sulfur here is not combined with anything except sulfur, so therefore it has to be 0. It's elemental. It's not a compound, it's just an element. In the case of thiocyanide here, or thiochlorate, SCl2, we're going to see that it's a binary compound, and chlorine as a binary compound is negative 1. So there's 2 negative 1s. The sum has to equal to 0. So in this case, the sulfur must equal positive 2. So we saw it just equaling negative 2 a minute ago. Now it has to equal positive 2. If this compound exists, then in this particular example, the sulfur has to be positive 2 so that it will balance. In this sodium sulfate, sodium sulfide here, this is a compound. We know that the sodium is in group 1, so there's 2 positive 1s here. Oxygen is negative 2. So there's 3 negative 2s. So I've got 2 positive 1s, 3 negative 2s, and it all equals to 0. That means that it's going to have to be whatever's left over to make 0, which is, in this case, positive 4. Last example, we have a sulfate ion. So in this case, it doesn't equal 0, it's going to equal negative 2. So we have 4 oxygens at negative 2 each, and the sulfur has to balance with that to give you a negative 2. So if I have 2 times negative 2 plus the sulfur equals minus 2, in this case it has to be positive 6. So we see it from negative 2 to positive 6. Confusing, but I think you can actually guess these things. Thanks.